The problem we have is 75 milliliter solution of ACL when an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 malaria of CaOH2. What was the concentration of ACL in the original solution? We want to find out the concentration in ACL in the original solution. What we know is the volume of ACL, which is 75 milliliters. We know that the volume times concentration equals moles. We also know when calculating volume, we need the units into liters. We also know the moles of CaOH2, which is volume times concentration, which is 27.3 milliliters and 0.157 malaria. And to solve for concentration, you'll need moles divided by volume, which is this equation. And we also know the moles of CaOH2, but we need ACL moles. The first step is find balance equation. The original equation was HCl plus CaOH2, but then we have to find this side, we have to switch the positive and negative ions among the compounds, which is H plus and OH minus, which get H2O on this side, and for this side we have Cl minus and Ca2 plus, which is calcium chloride on this side. And in the original, we didn't have the numbers in front of it, and so when we do, we have to balance the equation. In the original, we had H equals 3, Cl is 1, Ca is 1, O is 2, H is 2, Cl is 2, Ca is 1, and oxygen is 1. First, we balance the hydrogen atoms on each side, which is it was 3 and 2. First, we multiply the hydrogen chloride acid by 2, which will give us 2 times 1 of this hydrogen plus 2 of this hydrogen atom, which is 4. So now on this side we have 2. We multiply this by 2, which is 4. Put the 2 at the top. We multiply this by 2, also multiplying the oxygen by 2, which is 1 times 2 equals 2. So the oxygen is already balanced, and so now it's the hydrogen already balanced. So now we're to balance the chloride. We already have the 2, so we gotta multiply 1 times 2, which is 2. And on this side, we already have 2 chloride, which is 2. So this is balanced already, and the calcium is balanced already because on each side there is 1. This next particular step is not necessary, but I like to do because it's kind of extra, but I like it because it helps me see more. In this step, we convert milliliters to liters. We have 75 milliliters times 1 liter over 1,000 milliliters, which is 0.075 liters, which is the HCl volume, and 27.3 milliliters times 1 liter over 1,000 milliliters, which is 0.0273 liters of CaOH2 volume, which is a CaOH2 volume. The next step is converting CaOH2 moles to ACl moles. To find the CaOH2 moles is volumes times concentration, which equal moles. But they give us the volume and the concentration, which is multiply them, and there will be CaOH2 moles times 1 times 2 ACl moles divided by 1 Ca moles. We have to convert the Ca moles to HCl moles, so now it's converted, so you can cancel these out, and it could just be 2 HCl moles. We get 2 HCl moles from the balance equation, and we multiply it, and we get 0.008.57 moles of HCl. The final step is use the information above to find the HCl concentration. We know that the concentration equals moles divided by volume. We know the moles of HCl from the information above, which is 0.00857 moles, and in the problem they tell us that the volume of HCl is 75 milliliters, but then we convert it to liters, so then we do 0.0857 moles of HCl divided by 0.05 liters, which gives us the concentration, which is 0.114. One common mistake is not balancing the equation and just using this equation after you're swapping the ions, the negative and positive ions among the two compounds. That's a big mistake because it's not balanced. Another common mistake is not converting milliliters to liters, because in the equation we need the volume into liters instead of milliliters. That's a very common mistake.